So we've got a first order nonlinear differential equation here. dy dx equals x times y cubed, where y2 equals k. That's a condition we've got for our solution of this function, where k is an integer. So what I'm going to do is I'm going to try and solve for y of x. That's our goal, to find that. Then we're going to put this condition in and then see what happens to our solution for different values of x and different values of k. And at the very end of the video, I'm going to show an interactive graph of what happens to different values of k and different values of x. So you can see that at the end of the video. Okay, so first of all, let's get straight in and try and solve this equation here. So we want our y's on this side and our x's on this side. Well, x is fine, that's okay. So let's get rid of this y cubed on the right hand side. So we divide everything by y cubed. Okay, so now we're going to have dy over dx divided by y cubed, and that's going to equal x. So divide this by y cubed, just get a 1. Then on this side we've got this. Okay, now we've got our x's here, y's over this side. So now what we do is integrate with regards to x. So a nice big integration sign there to fit all that in, and a dx, and a nice big integration symbol there, and then dx. Okay, this side's fine, we can integrate that. This side here looks a little bit messy, so let's try and tidy it up a little bit. So our integral stands, our y cubed will stay in the bottom, and our dx we're going to need because that's what we're integrating with regards to. Now we've got a dy over dx. Now we can break this fraction apart to try and solve. So our dy will stay in the numerator and our dx will go in the denominator. And then we get the integral of x dx. So no need to do anything with that part, that's pretty straightforward. Okay, so now we've got dy, got y cubed, and we've got 2 dx's, which can cancel out. So that's really helpful. So now we've got the integral of 1 over y cubed. Y is a function of x, it's not a variable. So we just need to be careful with that notation there a little bit. And we've got equals the integral of x dx. Okay, so now this, we've got our dy. So now we're ready to integrate straight off. Power rule on this side, power rule on this side. Happy days, that's what we want. So now this is basically y to the minus 3. So our new power is minus 2. So we've got y squared. So I'm going to put that as y to the minus 2. And then we divide by our new power, which is minus 2. So now we divide that by 2, put the minus sign in front. Okay, so that takes care of that. Now what about this x dx? So now this equals x squared over 2 plus, now we didn't put a constant of integration on this side, that's always on purpose when we're doing these differential equations. We put the constant of integration on our right hand side. So now I'm going to call this constant just C1. Okay, now that's just a little bit untidy. I'm just going to try and tidy that up a little bit so I can see more about what's going on. So I'm going to continue this over this side. So now I've got minus 1 over 2y. So now I'm going to call this y of x because our goal is to find this solution here. So 2y of x, so that takes care of all of that, but with the squared term. So the 2 is this one, but I've got to take in consideration this minus 2, which when I bring it on the denominator just becomes a positive squared of all of that. Then that equals x squared over 2 plus c1. Okay, now I want to get this y of x on its own, that is my goal. So let's try and get rid of this constant here. So I've got basically everything multiplied by minus a half. So I'll multiply everything by minus 2, that will get rid of that. So if I times this by -2 and this by -2, let's see where that takes us. So multiplying that, I'm going to get 1 over y of x squared. Multiplying both of these terms by -2, I'm going to get minus x squared. So that will take care of that number 2 there. And this plus c1, I need to multiply by -2. So now I'm going to get -2 c1. Okay, now what I want to do here, I want to take the square root of both sides. So that would be a good place to start with these. So now I just put the square root sign in there and a square root sign there. I'm now going to take the square root of this, which will just give me 1 over y of x. That's the square root of that. And then that's going to equal the square root of this. But it's going to give me a plus or a minus value, as always, when taking square roots. So now I'm going to have minus x squared minus 2c1. Now this minus 2c1, that's a constant of integration, is part of that answer. We don't know what c1 is yet, that could be anything. So now I'm going to amalgamate this 2c1 and make a new constant and just call it c2. So now I've got 1 over y of x equals plus or minus the square root minus x squared minus c2. That takes care of that part of this constant here. Okay, so now all I need to do now is take the reciprocal of that, or I can just switch these things around. So now I'm going to get y of x equals plus or minus 1 over the square root of minus x squared minus c2. And that's my general solution. So that's where we are so far. But now I've got this condition here, y of 2 equals k. So now what I can do is I'm going to clear the board. I then use this condition where k is an integer, and let's work out some more slightly closer value of our function with this condition. Okay, so here's what we've got so far for our general solution. Now we can tidy this general solution up here because we don't know if C2 is positive or negative yet. So I can just change this negative sign into a positive if I wish, because that will not change any of our conditions whatsoever. Okay, so now I can branch this off into two kind of solutions if I wish. I've got a plus or a minus. I've got square root of minus x squared plus c2, and it's the reciprocal of that, and that's our y of x. So that's our main goal here, as in our general solution. But we know we've got some more information here. So y of 2 equals k. So let's try and move on a little bit and try and get this a little bit more narrowed down into what we want. So y of x, well here when x is 2 equals k. So I'm going to put a k on this side and call it plus or minus 1 over, or where there's an x I'll put a 2. So I've got the square root of c2 minus 4, basically, because x squared when it's 2 it becomes minus 4, so c2 minus 4. So now what I want to do is try and get this c2 on its own, and I know what my constant is here with this condition. So with this radical on here, that doesn't look so bad. So what I can do is now split this into two values. So I've got k equals minus 1 over square root of c2 minus 4. And here I'm just going to do the positive one on this side. Okay. So first thing to do, multiply both sides by the square root of c2 minus 4. Let's do that. So now I've got k times square root of c2 minus 4. So as I've got rid of that there, that just equals positive 1. So that's fine. Now with this radical here, I want to get rid of this radical. I can't get the c2 out without getting rid of the radical. So I'm going to have to square both sides. So now I've got k squared times c2 minus 4. equals 1 squared, which is 1. Okay, now let's expand these brackets here. So now I've got k squared times c2, so I can put that like that, and then minus 4k squared equals 1. Now I've got a chance here to get my c squared on its own. I'll bring the 4k squared on this side, so 1 plus 4k squared, and that's going to leave me with k squared c2. Okay, now just to get c2 on its own, I just need to divide by k squared. So that's all good. If I just put that as k squared, and then I can take this k squared off the board there on that left hand side. So c2 equals 1 plus 4k squared over k squared. So let's write that. Actually, I'm going to leave that there for now. So that's one value of my c2. What about this one? So same again here. Let's try a different tact on this. Let's just square both sides. So square that. Oh, let's write that too, a little bit tidier. And then square this one. So that'd be a legitimate action to try and keep this function equal. So now I've got k squared equals 1 over, so minus 1 squared give me 2. Minus 1 squared would give me 1. And square root of c squared minus 4 squared is just going to give me c2 minus 4. Sorry, not c squared, c2. Okay, now let's just bring these over on different sides. So now I've got c2 minus 4 equals 1 over k squared. Now I've got c2 equals, add 4 to both sides, I've got 4 plus 1 over k squared. Okay, so now just to try and get this looking a bit like this one, I can now multiply this 4 by k squared over k squared. So that will then give me c2 equals 4k squared plus 1 over k squared. So multiplying this by k squared over k squared is just like multiplying by 1. So that's why I got the 4k squared plus 1 over k squared. So basically my c2, regardless of each one, I've got equal values for my constant of integration. So 1 plus 4k squared obviously is the same as 4k squared plus 1. Okay, so now I'm going to take this all off the board, write my full solution here with my condition, and then we'll see what conditions we've got for our values of k and our values of x. Okay, so now I've got my solutions here that we've achieved so far with my c2 and my y of x. Now let's have a look at what's going on when I plug in my c2 to my solution. So now I've got y of x equals plus or minus 1 over the square root of minus x squared plus my c2. Now c2 here, I could write this as 4 plus 1 over k squared if I wished. So I could write that. So plus 4 plus 1 over k squared, or I could just write it like that, is also fine. So now what kind of conditions have I got for this function here? Now, first of all, if k equals 0, I've got some problems here because I've got 1 over k squared in my radical here. So that would be undefined. So k does not equal 0. Now, what about my x? Well, I've got minus x squared plus, I'll put this in brackets, I've got 4 plus 1 over k squared, or I could write it like that. Either way is fine. But what I want is to not have a negative number in this radical here. So what I need is to have this 4 plus 1 over k squared to be larger than my minus x squared. So let's write that. So basically my c2 must be larger than or equal to my x squared. So that's also a condition that I've got here. And then, so we've got these conditions here. K does not equal 0 for this condition here. and c squared is greater than x squared. So we want this part to be greater than this part. Now that is fine, but we've also got varying values of x and various values of k, which are going to be part of our rule here as well. So what we can say is this is also a movable singularity. So various values of x, various values of k, that is what we term as a movable singularity. So this solution here also has a movable singularity. So that will only occur for different values of x with different values of k. But these two are our main points for our rules for our solution. Okay.